Okay, hopefully this will be the last part of the video, but let's talk about zeros of a polynomial. So I want to remind you that the zeros of a polynomial are the x values when the y values are 0. Said another way, the zeros of a polynomial are the x values of the x-intercepts. So if we're looking at the x values of the x-intercepts, another way that we can say that is that zeros are solutions to an equation. And we can say that zeros are also roots, because if you were to plant a seed, you'd want to plant it somewhere in the ground. And you can think of the x-axis as the ground, and so you want to plant your seed in the ground, and that's why we call those roots as well. And in this class, all we're going to talk about are real roots. We're never going to talk about anything with an I in it, so there'll be no complex roots. So if you get something with an I in or the square root of -1, I need you to go back and redo it because it's not going to be correct. And finally, the zeros, going back to this, are the p of x when y is 0. So I'm going to use these things interchangeably. Also, I'm going to be using the zero product property because we're talking about polynomials. So if you take a look at f of x equals x plus 2 squared and x minus 5, that is a polynomial in factored form. And you can actually set this equal to 0. 0 equals x plus 2 squared times x minus 5. And you say that 0 is equal to x plus 2 squared, and then 0 is also equal to x minus 5. And when I take the square root of both sides, I have a plus or minus on this side, but 0 is the only number for which the plus or minus does not help. And you get that 0 equals x plus 2. And finally, when I subtract x or -2 from both sides, I get x equals 2. And for this one, I get x equals 5. So when I use the zero product property and set these two pieces, and by the way, the word that we use when we talk about these two pieces, we call them factors, because they're in factored form. So x plus 2 squared is a factor and x minus 5 is a factor. When we set those two equal to 0 and solve, we get the answer of x equals -2 and x equals 5. Those are called zeros. They're also called roots. They're also the x value of the x-intercepts and their solutions. So I'm going to be using these words interchangeably, so be careful. Speaking of, I have a polynomial. It is a second-degree trinomial, so using some of those vocab words. I'm going to ask you to find the zeros, and what you need to do is trade your f of x value for a 0 and factor what multiplies to be -3 but adds to be +2. That's x plus 3, x minus 1. Here are two factors. This particular polynomial, when you factor it, there are two factors done. Then use the zero product property and say x 0 is equal to x plus 3 and 0 is equal to x minus 1. And then solve. You get x equals -3 and x equals 1. And there's a couple of different ways that you can show this. Because these are solutions, you can use your beautiful solution set notation. But I'm hoping you get to see the relationship between a factor x plus 3 and its specific 0 is -3. So you have to imagine setting that equal to 0. I have some students right now who are like, I don't need to go through this step. I know that when x plus 3 equals 0, the answer is going to be -3. That's fine. So you're able to go from factor to 0 and back and forth pretty easy. So the next thing I need to tell you is this is a fifth-degree polynomial in 1, 2, 3, 4, 5, 6 terms. I do not expect you to know how to factor that. And in this class, we will not be covering the synthetic division or polynomial division necessary for you to be able to factor those. So a couple of things. This is the polynomial in standard form. This is the polynomial in factored form because it's been factored. So I can expect you to do trinomials, but I think it's outside of my expectation is that you be able to factor this. So when I ask you to find the zeros of something this big, I'm going to give it to you in factored form, and you're going to need to set it equal to 0. So you've got 0 equal 5 times x plus 1 squared and x minus 2 cubed. You have two factors, 1, 2. You're going to have two zeros because you have two factors. And setting that equal to 0 and solving, so I'm going to have 0 equals 5 times x plus 1 squared and 0 equals x minus 2 cubed. When I take this and square root both sides, remembering there's the, oops, I can't square root both sides, can I? Because the only way to square root both sides is to ignore that there is a coefficient of 5 that's sitting right into that particular spot. This 5 is a coefficient, and you have to deal with it first. It's really the leading coefficient because it's the thing that you do after you've done all the multiplication. So the first thing you need to do is get rid of it, which is nice because 5 divided by 5 is 1, 0 divided by 5 is 0, and now you can finally take the square root of both sides. And remember that 0 has no plus or minus, so you don't have to worry about that. And then you get 0 equals x plus 1, and x equals negative 1. There's my first 0. To find the second 0, I take the cube root of both sides. When I take the cube root of both sides, the cube and the cube root cancel each other out. I get 0 equals x minus 2. Adding 2 to both sides, I get x equals 2. Using my curly brace notation, I have that this function zeroes out at negative 1 and 2. The roots of this function are negative 1 and 2. The x value of the x-intercepts is negative 1 and 2. And the, what else? The solutions are negative 1 and 2. And I think I hit them all. So there's a relationship between factors and zeros. If I were to give you a function, and remember, you're reading these before I start, so pause the video if you need to read as I go on to the examples. So if you're seeing, if I'm telling you, hey, you have a polynomial, and your zeros of that polynomial are negative 2, positive 2, and 3, you need to come up with a function that models that is degree 3, which means the highest exponent of your polynomial when you're done multiplying can only be 3. Give it a name. I'm going to call it p of x. I don't know if it's going to have a coefficient there or not. And then start listing your factors. So let's give me, I have 3 zeros, and I'm going to have 3 factors. The only way that you had x plus something when it was done giving you a negative 2, what would have to go here to get a negative 2? Or said another way, I'm setting up the end of what we did up here, which was 0 equals x minus 2, and it gave me a 0 of positive 2. I need to know when I'm done with this, what's going to spit out a negative 2 if it was sitting here? And that's going to be a positive 2. So the factor that matches the 0 of negative 2 is x plus 2. The factor that matches a 0 of positive 2 is x minus 2. And the factor that matches a positive 3 is x minus 3. Now we have to check and make sure using mental math that we aren't violating the rule that x, the degree of f of x or p of x in this case has to be 3 and no bigger. So when I multiply these together, I'm going to get an x squared, and I'm going to multiply that by this x minus 3 term, and so I'm going to add the exponents, and there it is. When I'm done multiplying, even though I don't have to multiply, I'm going to have x cubed, which is exactly what I want. That's what it means to have a degree 3. You're welcome to use your Desmos. Pause the video at this time, use Desmos, and make sure that you're going, you have a x-intercept at negative 2, positive 2, and 3 from this particular graph. And if you're like, hey, I can't put an a value in there, well, you don't have to. If you don't want to have an a value there, you can just say that it's 1, and here's a possibility. But if you wanted to have an a value there, you can write an a value in, like negative 1/2, x plus 2, x minus 3, x minus 2, x minus 3. So making sure that this all works by putting it in Desmos. And if it's going to work, it's going to make sure that it goes through an x-intercept of -2, 2, and 3. So pause video and make sure you do that. So since you're back from going to Desmos and taking a look, you know that there is a relationship between the factor and a 0. There also happens to be a relationship between the factor, now remember here's a factor, and its multiplicity. We say that a factor has multiplicity 2 when the exponent that's on the outside of the factor is 2. This one has multiplicity 3 because that's the exponent that's attached to the factor. And these multiplicities have a huge role in telling us what type of touching or crossing is going to happen at that x-intercept. So taking a look at this, you're going to need to go to Desmos because you're the one that's going to come out and say that if in example 3b, so that's the one I was just talking about here, it had an x plus 1 squared and then an x minus 2 cubed. And we just saw that on here. And you've already gone to Desmos, or you need to pause and go to Desmos and actually graph this whole, either this one or this one. These are the same function, just one's in factored form and one's in standard form. I need you to go do that. And I want you to tell me and notice what's happening at x equals -1 and what's happening at x equals 2. And come back to the video. Because when you come back, we're going to actually fill in what you noticed from your Desmos. Go ahead and make sure you've gone to Desmos and graphed 3b. And you'll notice that when a function, the factor, has even multiplicity, the graph of the graph of your function touches the x-axis at that x-val. So it touches. So for example, it went like this, or it went like that. But when it has odd multiplicity, it crosses the x-axis at that x value. So what does that look like? Well, maybe this is your x-intercept, that's a cross, or that's a cross. Which is so cool. So the multiplicity of a factor can tell us what's happening at that x-intercept. Are you touching or crossing? Which I think is so cool. So I do this in a table. I go through and talk about multiplicity in table form. So when we take a look at example 5, I've given you some really cool polynomial, and I want you to list the 0 and their multiplicity, and I want you to tell me if it's even or odd, and I want you to tell me if it touches or crosses. So this begins with, this has no x, so it is not a 0. The next one is x minus 2. So the factor of x minus 2 is going to spit out a 0 of positive 2. At positive 2, the multiplicity is 1. If it's not written, it's 1, which is an odd number. In fact, it's the smallest odd number. And if you have an odd multiplicity, you're crossing at that particular 0. Continuing with the other factors, the factor of x plus 1 cubed spits out a 0 of -1. Its multiplicity is 3, which is an odd number, which means you cross that x-axis at that point. The factor of x minus 3 to the 4th spits out a 0 of positive 3. The multiplicity is 4, which is an even number, which means that you touch at that x-axis. Overall, though, we need to find the degree of the entire function. The degree of the entire function is the highest exponent when it's in standard form. Well, I'm not going to spend a whole bunch of time putting this in standard form. That's a lot of multiplication. Instead, I'm going to use my mental math and say, this is going to produce an x, this is going to produce an x cubed, and this is going to produce an x to the 4th when I'm done doing it. gathering up all of these x's under multiplication, because I'm going to have to multiply all these together in the end if I wanted to go to standard form, it'd be x to the first times x cubed times x to the fourth, which is x to the eighth. The degree of this function is a degree 8. That's an even number, which means the shape of this is going to be a parabola opening up, and I kind of made that a flattened out parabola because we saw as the even number gets higher and higher and higher, the bottom of that flattens out a little bit. Either I'm opening up, which means that I did not reflect this over the x-axis, or I'm opening down, which means I did reflect this. Oops, that did not help. Let me turn that off. Over the x-axis. How do I figure that out? By remembering this transformation right here. If there is a negative number right there on the outside, it means that you reflected this over the x-axis. That means, that piece right there means that this function is going to be in the downward facing parabola, which we said before was as x goes to the left, that's negative infinity, you should expect your function to also go down. And as x goes to the right, you should expect your function to go down as well. So that was from a previous slide is when we're using that. We call this end behavior. This right here is literally called end behavior. Because I can use the zeros and their multiplicity to tell me what's going on in the middle of the function, and I'm going to use the degree to tell me what's going on out at the positive and negative infinities. So we're going to talk about this in class more, but here is the limit notation. Some of you already have. That's fine. But using this information, go ahead and grab Desmos, graph this function, and make sure that all of this is true. Go ahead and make sure all of that is true, because I would think that being able to verify without Desmos is going to be really important. We're going to meet up on page 6 in another video.